Hi, I'm Abdullah Muhammad, and my major is Engineering and Artificial Intelligence in Seven University, Malaysia. So, in this video, we will be talking about some applications of integration. So, how can we apply in a real life situation and also in mathematics? So, let's say this is an equation 3x plus 5 equals 3. So, we can find out the root from this equation by taking out x. We can substitute the rest in right side, then we can find out the x value. But in this case, when the power is 2, then we can find out x equal negative b plus minus root over b square minus 4ac divided by 2a. This is another root. But let's say the function is very complex and also we cannot find out the root of the function. So in that case, Newton method is a very crucial method to find out the complex issues from equations, finding the root. So let's say we sketch one graph like this, one equation. This is fx. So this function, let's say we find out the we guess that like this is the root of this function, but we are not sure. So how to find out? Like let's say we want to guess one root here that we can mention as x naught. This is the initial one. So if you say x naught, so the location of this point is x naught 0. This one is x naught f x naught. That means x point and y point. So we want to know the slope of this equation. So if we want to find out this slope, then we can find out the later slope and also later slope. Then we can find like many iterations. Doing many iterations, many derivative of this slope, then we can find out the real root. First of all, we look for this one. So this is the difference x naught and x1. This is the difference of x. This is the difference of y. So this slope is a derivative of this equation, the derivative of this equation, and also y divided by x. So y is y this point and this point negative difference, and x is this point and this point negative. This point this difference, this difference is x. So this one we can switch here and also we can switch here. So x1 and x0 here, so we can put it rest. So x1 we can say this one is the higher one, so n plus 1. This is the lower one, so we can say xn. So this is we can put the rest is like that. So this is the general equations to find out the root of the equation using Newton method. So let's look one example here. So in this example, let's say 3x negative cos x negative 1. So it's really very hard to find out this root using this kind of general equations. So in that case, we are going to use the Newton-Raphson method. So firstly, we need to look for the derivative. As you can see, the derivative. So we can look for this derivative. 3 cos x will be sin x. So this one is fine. So in this case, we want to guess two value, like which can be close. Like we say also f of a and f of a, f of b. The resultant of this multiplication will be less than 0. So we guess first one is 0 and second one is 1. So if you substitute 0 here, so it will be negative 2. If you substitute 1, it will be 1.46. Let's say if you multiply, obviously it will be less than 0. So we since we know this equation, so in that equation we see that this one x n plus 1, this is the root, and firstly we can put it here, and second one and the third one. So here, sorry. So firstly we can guess 0. So if you substitute 0 here, so you will find negative 2. If you substitute 0 here, you will find 3. So if you substitute everything in this equation, you will find this value. So this value I will have to use for the second time. For the second time, like in this graph, if we find one iteration, we will have to second time do, third time, and also so on. So this case, we are going to use 0.67. So if you use this one and substitute it f of x, then you will find this one. And if you substitute it here, you will find 3.62. And if you substitute everything in this equation, you will find this one. So same thing, you will have to do the iteration. After doing the iteration, second the repeating system, you will find this one same. So that means this both same. That means the root is 0.61. So this is the Newton and Raphson method. So now let's look another application, moments and center of mass. So for the time limitation, I will be doing a bit short calculation. So let's say we want to find this center of mass. The center of mass is here, x bar. So the difference, as we explained before, the difference, distance, and also the mass multiply, same. This one multiply with mass and distance equal. So in that case, this one is the 0 point, this one is the center of mass. So if you want to multiply with m, and this difference is x bar and negative x1, so you will find this one and the mass. So this difference is this one and also mass. So if you take out this x bar, this one will be here and this one also will be here. So this one will be substituted left side, and if you put x bar, it will be downside. So let's say these are the moments of multiplication with the distance and the location. So this is the moments of center of mass, this is the total mass. So we can use this equation like moments divided by total mass. So if you consider something two-dimensional, that means here one mass, another one is here, another one is here. So same thing, we can say center of mass, this is about y-axis. In y-axis you find this one, multiplication with distance and mass. Same thing, if you have many n times location of masses, also you can m1 and m1x1, m1 m2x2, like that. So same thing, this one is center of mass about x-axis, y-axis, this one is x-axis. So you know that this is the center of mass. Center of mass, that means the moments divided by mass, same as we explained before here. So this one will go for many times of masses. So this one my divided by m, because this is the total mass and this is the center of moments of the y-axis. So for this here, if you want to find out the center of mass for y point, you will have to use this one. So this one means, actually this one is here, this one mx, this one is mx, my. So this one is mx, but you will have to consider this one is y-axis, rotating y-axis. So these are the center of mass and moments that we consider. So if you find out something centroid, like the mass is divided in evenly, so in that case we know that rho is equal to m over a. When you have two-dimensional configuration, then you will have to say this one. When you consider something three-dimensional, then you say mass over volume, but this one is two-dimensional, so that's why mass over area, we can consider this one. So area we also know by finding the area of this both functions. So this one negative, this one, since this one is upper side, this one is lower side, this one is bigger, this one is smaller, so that's why we can find out the integration of this area. So by using this area, and also we can find out this y value by taking average. So we substitute everything here, since you know that the moments of x is equal to mass and times distance, as we explained before. So same thing, you say the density and also the area with y. So then you can find out the y point of this mass. So this is the equation, as we said, the calculation. So like you can multiply both f square by xg square. So then you find out this one. Rho will be here. Rho will be cancelled out, and 1 over 2a. Then you will find out this one. So this one is the y point. So if you want to consider something with x point, when you consider x point, then you will find out this equation. So this equation is difference with only, you need to multiply with this x. Here both square and 1 over 2a. The area will be 2 times. So let's consider one example. In this example, you have two equations. You want to find out the center of the mass from here, centroid, I mean, from this area. So this equation and this equation, let's sketch the graph. So root over x will be this graph, and the straight line will be this one. So I will have to find out this value and also the center. So from that case, we don't know the boundary. So since the intersection point we want to find out, substituting here, so we can find out 0 and 1. So if you want to find out the area, so you will have to start from 0 and 1, since we got, so this one negative this one, since this one is upper side, this one is lower side. So in that case, you will find out the total integration, and also you will find out the area, 1 over 6. So this one is the area of this point. So since we got since we are looking for the x point and y point, so as we explained before the equation, so this is the x point, the calculation is 2 over 5, the x point, and the y point is 1 over 2. by doing the integration part. So this is the mass, the center of this point, that means x and y, 2 over 5, 1 over 2. That means this is the center of the mass of this area, that is the mass is divided or distributed evenly in that case. So yeah, these are the two total applications of integration that we normally use in our real life situation. So later we will be explaining the applications of integration in especially in economic system like consumer surplus. So till now, coming back. So we already covered in this video application of science and engineering, especially using integration. First one is Newton-Raphson method. The second one is center of mass and centroid. So the third one is in economic section, consumer surplus. So let's say this one is the sketching graph of the consumer surplus. So this one is the demand curve. This one is the demand curve. This one is x-axis. This one is for price. This one is for price. This one is for the quantity. So in the case, we say like you want to buy one product from the market or any goods, anything. So you're willing to pay this much. From home, you are willing to pay, you are ready to pay this much to buy any product. But in market, you find the value is decreased. The market value is decreased. That means this is your profit. That means this is surplus. Actually, it's very interesting, like the price is fixed here. This is the line, straight line. But you were willing to pay from home this much. So that means you're paying less than you were willing to pay. That means this one is the surplus for consumer. So for every people who are like going to pay intentionally more than the fixed price. So these are the all like this total area is the consumer surplus. If you integrate the total area, you will find the consumer surplus for this amount of product. So let's say this amount you want to buy this value. So this point will be sketching here, x and p. This is the x amount, this is the price. So this is the demand curve. We can say p equal px. Dependent value is x. Independent value is x. That means the quantity, how much you want, and the price will be dependent. So this is the curve of demand curve. This is the price curve. If we subtract from this one to this one, then you can find the total integration from 0 until x. So okay, let's look one example. So savings per unit, number of unit, if you multiply, you will get this equation. Normally we can say 0 to x, the curve negative, the price. If you integrate, then you will find the total consumer surplus. So for example 1, the equation is this one, 1200 negative 0.2x negative this one. So find the surplus, the level when the level is 500. So let's say since the number of sold product is x equal 500, so you substitute x equal 500 here. So if you substitute here x equal 500 in this equation, you will find 1075. So then we will put the value in this equation, 0 until 500. So if you integrate from here 1200 negative 1075 125, then the same will go. And if you integrate, so this one will be 125x, this one will be x squared divided by 2 if you divide by 0.1. So this one x3 and divided by 3. So then if you substitute this value here, so oh sorry, this one is 0. So from boundary to 0 to 500. So if you subtract from this one to this one, you will find this value. So this is the consumer surplus when they sold 500 products by this equation. So this is the consumer surplus when you are actually consumer surplus is like willing to pay negative the fixed price which is already fixed by the market. So the total subtraction of the total integration of the area, so you will find the consumer surplus. So these are the total 3 applications of integration, especially used in science and engineering and also on. So that's all from me.